In the previous lesson, we saw how the rip feature is used to break apart solid corners and replace them with gaps. The next step in converting this part into sheet metal is to introduce bends to replace the sharp corners that remain. This is easily done using the Insert Bends icon from the sheet metal toolbar. This brings up the Insert Bends property manager. Portions of this interface should look familiar. Here at the bottom, you see a section called Rip Parameters, and this is exactly the same as the rip command from the previous lesson. Since the rip and insert bends features are used together quite often, SOLIDWORKS has included the rip feature in the Insert Bends property manager. This allows you to accomplish both features at once instead of using the rip feature by itself. And let's take a look at the rest of these settings. A selection box at the tip prompts you to select a fixed face or edge. I'll select the bottom face and specify the default bend radius to be used in place of the sharp corners. I'll use the K-factor bend allowance type, using the default 0.5 ratio. The auto relief section is the same as we've seen in several other sheet metal features. You can have SOLIDWORKS introduce rectangular, tear, or O-browned relief cuts as they're needed. Once I click OK, SOLIDWORKS notifies me that auto relief cuts were made. As you can see, the part now has bends in place of the sharp corners. This part is now converted from a regular solid into a sheet metal part that SOLIDWORKS can flatten. Because we took the approach of converting a non-sheet metal part into sheet metal, 3 new features were added to the Feature Manager tree. First is the sheet metal feature, which is the result of using the Insert Bends command. If you were to edit this feature, you would see it's exactly the same as the sheet metal feature we've seen in previous lessons. It contains the default bend radius, bend allowance, and auto relief settings. The second new feature is Flatten Bends. This feature contains information of each individual bend. If you were to edit these bends, you could change things like the bend radius used and the order in which the bend is applied. The third new feature is Process Bends. This is the feature that transforms the flat pattern into the finished part. Notice the Feature Manager tree now lists the flat pattern feature we've seen in regular parts that are designed as sheet metal parts from the beginning. Clicking the Flatten button unsuppresses this feature, and we can see the new flat pattern. There's also a new No Bends icon available on the sheet metal toolbar. When I click on this button, the tree rolls back to just under the sheet metal feature in the feature tree. This represents the part in its sharp corner, or pre-sheet metal state. Now that this part has been converted into a sheet metal part, I can use any of the sheet metal features we've seen in previous lessons. For instance, I can add an edge flange. What I have now is a hybrid sheet metal part. It started as a converted non-sheet metal part, and now I've added a regular sheet metal feature.